Thanks, everyone. Thanks, Matt. I'm going to, for running smoothly, I'm going to read something first before I introduce myself. I'm going to set back the backdrop for my conversation. So on the screen is an email, and if you see the email, let me bring it a little bit closer. This is actually a real case. This is I can call the name. Palm Transport is a publicly traded transportation company, and they employ quite a lot of owner-operators. One of the dispatchers at Palm is outlining to the owner-operators some issues about information that they need. So as you can see, she's requesting that drivers relay to her a set of information. Down there you see a set of information. She needs to know the load, the truck, trailer information, the time in, time out of the load, bill of lading, the pieces, that is how much pallets or what the weight is of the truck, and the seal number for the trailer that the driver has. Keep that in the back of your mind while we get into the presentation. So this morning, I'm going to talk a little bit about driving operational excellence with OSIsoft's connected vehicle in real-time freight with respect to DOT. What we will cover is we're going to talk a little bit about Tiemac, the freight industry, the US DOT, what we're doing with them, how OSI fit, and let's go through a little bit of demo with you. So let's get driving. Talk about. So we're based in Atlanta. We started operations in 2014, and we have about 50 beta customers lined up, our accounts lined up. We are in beta rollout mode at the moment, and we have quite a bit of strong partnership that we boast. Those are our partner list of our partners. Microsoft being one of them. As you know, see, I'm using one of their tablets. OSIsoft, Verizon, AT&T, Esri, Telit, to name. We have 10 very strong partnerships in the solution that we're rolling out. So let's talk a little bit about what the freight importance to the U.S. There are just under 120 million households, about 7.5 million businesses, and 89,000 government entities that rely on freight movement across the country. Freight transportation industry comprises 11.7% of GDP, and I hope you, yeah. What I want to zero in on is, of this chart, is what the trucking industry does with respect to the GDP. So in 2011, the transportation trucking industry contribute 28% of the 11.7%. That is about 3% of GDP is by trucks that moves freight across the country. Now, in 2011, there were just under 4 million miles of infrastructure attributed to public roads across the country. And freight travels over, as you know, an extensive network of highways, railroads. We talked about that earlier on in the earlier presentation, waterways and pipelines. However, basically what you're not seeing is we're talking about different distances that trucks travel across the country. And for each mode, each distance sector, trucks carry the most of the freight across country. Whether you're talking about 100 miles or 2,000 miles across the country, trucks for each mode carries most of the freight across the U.S. Not rail, not water, not air, it's trucks. And that's basically what you're not seeing in the slide. Now, just to zero in a little bit more on some data, this is to set the backdrop. The transportation, as I said, trucks carry in 2011 about $670 billion worth of freight across the US, Canada, and Mexico. And you can see, relative to trucking, where the other modes of transportation does in terms of transporting freight across the country. Again, in this, what you're not seeing is trucks makes up 60% of the freight that carries across the entire country for each mode across NAFTA. Now, let's look at what's important to us. Of the total number of trucks in the US, or companies that are carrying freight, in 1990 was just over 214. By the time 2011, there were 714,000 companies that are involved in the trucking and transportation industry. So you can see a significant growth over the years. It is this is, we're talking about over-the-road transportation now. It is this group that we have zeroed in on. Let's talk about the DOT and how we got involved. We are working with them. They have set up a test bed in Michigan that they're working on connected vehicles for the future. We are working with them on that test bed scenario, and they're building quite a sophisticated infrastructure, concentrating on all mobility applications with respect to transportation, trucking being one of the most significant ones. Now, they have, as I said, developed what is called a concept of operation, which defines how they are going to roll out connected vehicle infrastructure, as well as the vehicle-to-vehicle mode of communication for the country over the next 4 to 5 years. They've used very sophisticated, architecture called connected vehicle reference implementation architecture, and there are 9 elements to it. I'm not going to go through each in detail, but what I want you to see, just to show you how complex it is. So this is a few of the elements that they have defined in this infrastructure. One is physical object is supported by a single application for registering the vehicles or anything that is going to talk to this infrastructure. Then they have, if you look at the bottom there, Saudi Michigan Situation Data Clearhouse. How does data comes in and go out? How do you authenticate users or elements that are interfacing in this infrastructure? As I said, there are 9 of them. I'm not going to go through in any detail. The slides will be available online. So for those that what you're not seeing now, you'll be able to see it. They will be available online. But the one that is most important to us is this one, what is called a third-party application center. As part of that infrastructure, the government is allowing third-party companies to join in their infrastructure to build peer-to-peer applications that any company can tap in for profit. So you can contribute to this infrastructure and allow for your piece, or what we call node, to be part of this macro system, and anyone that taps into it, of course, you're on your own business case as a company, you can set up and how you charge or your commercial mode, it's all left to you once you're following the architectural design of the government. Now, so how does Pi fit in all of this? Well, we began, as I said, last year I presented here about what we're going to do, what we plan to do. This year, And how we're going to, the subject matter was mobilizing the power of data, enabling on-highway vehicle. That's what we talked about we're going to do. Funny enough, again, we started out not because we have a theory. We were working with some small owner-operators, and they were having real problems. A pie diagram here, again, is not showing properly, and I apologize for it. But basically, we were able to see some of the areas where we could bring efficiencies in helping commercial vehicle, over-the-road commercial vehicle. Although we were concentrating on owner-operators, the point to make, and if you reflect on my email that I read earlier on, was that Palm Transport is a publicly traded company, but they're made up of small owner-operators that carries their freight across the country. In fact, 97% of the trucks across the country is owned by owner-operators with 20 or less in their fleet. So like a Swift or Schneider, J.B. Hunt, those you might see as very big organizations, but they are made up of small owner-operators that have fleets of less than 20. Okay, so this we were working with a small owner-operator, and we saw where we could do something to help in optimizing and increasing their efficiencies. In general, some of the challenges that it's faced is, sustainability metrics are not effectively measured. So, they don't know how well they're performing. There's no visibility in what is going on. Again, my email, if you recall, points to that, because here is the dispatcher asking questions. Where's the truck? What load are you carrying? When are you going to deliver the load? What is the bill of lading? Because that's a document that moves right across from shipper to customer. That goes through broker, goes through the carrier, the driver. There's no visibility in that information. For owner-operators, for large fleets, you may see some of them that owns their own truck may have, some device like a Qualcomm device, and they are able to manage it for their own fleet. But because, as I said, most of the trucks they use are by independent owners who don't have anything, there's no visibility. And again, that email was to just demonstrate this lack of visibility, what the issues are. Now, today, just over a year, with the help of OSI, our partners, we have an infrastructure that is built out now. It's pretty robust infrastructure, starting from the vehicle. We make both, it's an end-to-end solution, so we provide the device, IoT device, as well as we provide a turnkey solution that deals with telematics, as well as back office operations. So the accounting information, the logistics information is all rolled into our solution. And everything is fed into the cloud, and from there we act upon it. All of our servers, PI systems, are all in the cloud. So let's roll back the curtain a little bit and go into a little bit more detail on some of how this works. So in the freight transportation space, where does the greatest opportunity lies for us to bring efficiencies to the table? Again, looking at this is where over the last years, where most efficiencies have been achieved. Our earlier presenter spoke about the rails. Well, the yellow line is what you need to focus on, and not the yellow line, that very, what you call, what color you want to call that? This line I want you to focus on. And that's the line that one of the greatest need is in the general freight transportation that needs efficiencies. They will operate a very thin margin, about 3% net is what the profitability is. It's a very thin margin. So any improvement in efficiencies will help the trucking industry. Fuel is extremely high, maintenance is extremely high, so anything you can do to touch on those will help. So what's the next step in our journey? We are now integrating our system with working with the DOT, and we put a proposal in place with them. And basically, I'm not going to read that to you, but we are going to provide our system, our network, our infrastructure as a node, as part of a third-party application center. So anyone who wants information, for example, on a truck that is on our network, can get that information and then add value to that, whether it be their own logistic application or just want to get some data, they can do so because we're a part of that node of the government. And by using the infrastructure, the CVRI infrastructure, you can tap into it and get information through our node. So the proposal we focus for the government is that we are going to look at just over-the-road vehicle. Now, our application doesn't just it's not just for the over-the-road, any commercial vehicle, but we happen to concentrate on the over-the-road sector because we believe that that's where the biggest opportunity lies. So the key components are we're going to provide real-time data capture. We're going to do creation and expansion of access to high-quality real-time and over-the-road data from connected vehicles. Provision of a real-time monitoring and management tool based on vehicle-to-infrastructure connectivity. And advanced telematics solution with back-office operational excellence. That is, we're not just providing an island, a logistics island that sits out there. We're connecting it to the business side so that, an owner-operator or a fleet owner is managing his cost, and he knows how that affects his bottom line immediately. So it so happens that what we're going to do, what we provide on our system aligns with the needs of the government. And these, under the Federal Highway Administration, one of the things that they are looking at is smart roadside development. How do they get information from traffic, particularly commercial vehicle, when on the road, for regulatory perspective, but also for planning? As I said, part of the reason why I gave it the data on the GDP is that the commercial vehicle space does impact significantly the bottom line of the country as well. So the government is aggressively putting in plans to manage the infrastructure because there's just so much that is going to grow, and there's just so much limited real estate, so much more. You can't build roads enough to meet the traffic, to meet the demand. So you have to find ways of efficiently moving on your existing infrastructure. So again, this is just a rehearsal of showing you that our view is aligned with the government's view. They want real-time information, want data, want unique vehicle identifier information that is stored for government to interact upon. One of the things is a commercial vehicle space is very regulated. The driver has to follow what is called hours of operation. You can only drive for so many hours, and maximum 11 hours in one day. You can drive, it cannot be continuous. You have to have logs that when the police stops you on the road, they can present. They also have to have the equipment well intact for safety reasons. They can easily get tickets just for not even having a light. Can give them a ticket that costs significantly, because on the wrong side of the equation for the owners is that it's a revenue generating mechanism for the state, local government as well. So let's go in a little bit now. I'm going to show you a few diagrams. Again, you're not going to see it very well, but to just show you how this sophisticated infrastructure that the government is undertaking to build out. So our focus, I just want to re-emphasize, is operated a virtual transportation information center would provide at core a peer-to-peer data exchange service in which our crew account, that's our product is called, using P2P application will generate and distribute on-demand and for-profit information to peer-to-peer support, roadside equipment, and other third-party application connections to the government's infrastructure, CVRI infrastructure. This is the government's DOT architecture, and I just wanted to show you how we fit in. Again, you're not seeing it very well, but we're one of the nodes on this sophisticated infrastructure of how it's connected, how data is going to be transferred, and how you authenticate as a provider on this network. So what these few slides do is to speak about that, how it is done, and how we fit in, and how Pi and the Microsoft infrastructure that we're using is all tied into this network by the government. Okay. I want to just go through to the demo. I'm going to bypass because you can't see some of these screens. So let's switch a little bit and go into a real, hopefully we can show you some real data, some real information coming in at the moment. So I'm going to switch here. We're going to talk about phrase logistics management, real-time data management with Pi system. I'm going to show you some of these. We use almost all of Pi core systems. So we use Pi server, we use event frames, we use notifications, asset analytics, asset framework. We use all of that. Pi process book to generate the user interface graphics that we do. We use Pi core site and web parts as well as web services. We are tying in with Esri system as well. So we're using all of that, all of Pi main technology in our solution. So let's look at, just to show you something, I'm going to switch a little bit out of the PowerPoint presentation. And then go online. Here we go. Okay. What I want to show you now is actually there are 2 trucks right now somewhere in the country. And for interest of time, I'm not going to take you through the logistics of how those trucks were dispatched. They're actually carrying loads on right now. But if you recall my conversation, my email, wanting to know that set of information, again, it brought that email up because it brings relevance to what we're showing in terms of managing logistics. So up here, and these are actually real data that we're pulling in now. So if we look at this is something that is a truck that has been dispatched with load. Right now, that truck, you can see this telling us the movement of the truck. It's actually in Arizona at this moment as we speak. And if I just hover over this, you will see, again, don't worry the time that shows, but basically, if you look at D002, that contains quite a bit of information that tells you the driver, it tells you the time where he was at a spot, as well as the dispatch that carries all the logistics information. Now, any of the stakeholders, a shipper, a customer, a carrier, or a broker, can go in onto the site, search for, using the bill of lading, and pull up information relevant to what they need. So where's the truck? What load are you carrying? What's the seal? Who is the driver? Who is the carrier? Can be answered in real time. That's one. Let's look. And then we are using not only information on the truck, what we can do as well is, this is core site. So we're pulling in about 140 data points on a truck. Includes all of the important parameters, the temperature, oil, the brake, all of that information is going real time into the cloud, fed through Pi, and then positioned in core site. And this is, right now, it's telling me that the truck is actually not moving. There's no, there's not a lot of data coming in at this moment. But if you look at that VIN number, you could go out online now and type in that VIN number, and you'll see that that's a real vehicle. In fact, I think it's a 2004 Volvo that is on the road somewhere in Arizona at this moment. This to show you, what we wanted to show you is, this is real-time information coming off of the vehicle at any time, and any stakeholder who has interest in that load that the truck is carrying can have that information in real time. Now, we're going to do one more switch, and hopefully we don't get into the issue that we just have. I want to switch to an app that the driver carries, and they carry a tablet inside the truck, and does what is, as I mentioned earlier on, what's called hours of operation. It's key to a load being delivered on time, key to meeting regulatory requirements. So if a police stops a truck on the road, he should have a log of his hours in service. He can only work a maximum of 70 hours in 1 week, or 60, depending on what cycle he's on. He has to be able to show all of that. We're feeding that information into Pi. We're doing the calculation there in real time, so the driver doesn't have to manually record when he stops or when he starts. We're getting that information in real time, and we're putting it in. So the driver needs to only state what state he's in, whether it's on duty, off duty, in sleeper. So I'm going to just show you quickly an app that the driver uses. Again, it's real-time information tied back to that load. So let's see if we don't run into any problems. Okay, here we go. I don't know my, okay, 1Q. Okay, so tells you right now that if you remember that load, that dispatch D002 tells me the driver's on duty. Basically, he would have this in his cabin. So what we've done is to patch it so we can show you a demo, basically. So basically, he would either click, it will tell you, yes, I'm on duty. Are you sure you want to get off duty? And that is logged in. That information is fed back into Pi. Pi then relates it, and that graph, in terms of electronic log, it would produce this result relative to his traveling, where he is, whether he's on duty, he's off duty, in the sleeper, that information in real time. So he doesn't have to fill it in. Okay? Yeah, okay, right. This is an in-cabin application for the driver, again, tied back to the whole real-time data infrastructure that we are creating. I'm not going to go back into the PowerPoint because it wasn't showing very well. But let me end by saying what we have done is last year, just over 14 months ago, we began a journey, a vision of this is what we're going to do. 14 months after, with 10 very strong partners, we have a system that is out there in real time, providing information, solving real problems. And we see this going further because, as I said, we are working with the government to tie it into their infrastructure that they're developing for the connected vehicle of the future on highway infrastructure. I apologize for the hiccups. Again, we're using a preview version of a Surface by one of our partners, and I apologize for that. But that's our end of the presentation. If you have any questions, feel free to ask me at the moment.
Thank you for covering.
Yeah.
So we're getting compressed into the next session. If there's a compelling question real quick, we can take one, and if not, Michael will be around for
Obviously, we're getting to a trend where trucking is probably the most gonna heavily automated in the future, right? Like, we're getting to. There's a couple different shops that's working on kind of automating the vehicles themselves, that can taking the drivers out of the equation. How do you see like this technology being fitting into that paradigm?
It will fit in very well because that vision is of fully automated in the truck is 10, 15 years out. Secondly is you will still have, there are about 2.5 million trucks on the road right now, and that you'll have a combination going in. Thirdly, even with fully automated trucks, it still has to fit into the infrastructure that the government is building. The driver has to interface, and the operational side of it in terms of how do you take that data, put it back and make sense to the business case of me running that operation has to be tied back in. So we will evolve with the automation process over the next 15, 20 years as we go to full automation.
Thank you. Thanks, Michael.
Thank you very much. Yeah.